Hey math kids, today we're going to talk about the properties of rational and irrational numbers, but I wanted to start with just a review of just the sets of numbers that we've talked about, or that you've talked about in other classes. So we're going to start with the counting numbers, which in math we're going to call natural numbers. So that's just 1, 2, 3, 4, etc. So these are the natural numbers. So we pronounce this the set of all natural numbers, or just natural numbers for short. Okay? Then we have the set of all whole numbers, and that just adds 0 into the mix. So it's just all the natural numbers, but we also have 0. And then from here, we get the integers. So that's a z, script z. Integers. That gives us all of the negative whole numbers, 0, and the positive whole numbers as well. From here, we can create the rational numbers, which is a script q. Now, we can't really write it in this same form, so we just write like a definition. It's just going to be any number you can write as an integer divided by an integer, but the bottom cannot equal 0. So the only integer that can't go on the bottom is 0, because that would create division by 0, and that's undefined. So since we're talking about rational numbers, I'm going to go a little more in depth on this, since that's the topic of what we're doing. So rational numbers, even though this is the definition, there's 4 ways that we can recognize a rational number. So the first one is just any integer. So for example, -2, 5, 1, 0, -632. Those would all be rational numbers. Now, the other one is the actual definition. So if we have an integer over an integer, or like a fraction is another way you could word that. So -2/5, 1/3, 537 over 692, etc. So that's, once again, these are the ways to recognize rational numbers. So if we see an integer, integers are rational. If we see an integer over an integer, those are also rational. Now, as far as decimals, we have terminating decimal. So all that means is a decimal that stops at some point. 1.5, 3.261, 7.32. All of those are decimals, but they stop somewhere. Okay. Now, the last way to recognize it is a repeating decimal. And for a repeating decimal, that's like 1.6 repeating, 5.727272 ... repeats that forever. All of those can be written, all of those are rational numbers. Now, I just want to do a quick example of each of these to show how they could actually be written as integer over integer. So if we take, I'm going to zoom out on this so we can still see these. So if we take a whole number, so if we take the number 5, for example, we can write that as 5 over 1. 5 over 1 is equivalent to 5. 5 is an integer, 1 is an integer, so it's integer over integer. This yellow one, integer over integer, obviously that works, so we're going to just move on from that. Now, terminating decimal, so let's just take 1.5. 1.5 is 1.5, so we could write it as 1 and 1/2. Or we could write it as 3/2. If we type these all into a calculator, they would give us the same output. And they're just all equivalent ways to write the same thing. But since 3 is an integer, 2 is an integer, 3/2, any of these decimals, we could, if we took the time, we could write them as a integer over integer. Now for the blue part, repeating decimal, I'm going to take the number 0.333 repeating, which I think most of you know is the same thing as 1/3. Now I don't know off the top of my head what 5.727272 repeating is, but since it's a repeating decimal, it could be written as an integer over an integer. Okay? Now we're going to move on to irrational numbers. And often it depends on, there's not like an official way to write irrational. All these are like official standard, like the Q, the Z, the omega, and the script N. Sometimes you'll see it as a script I, or sometimes you'll see it as the complement of Q. And we haven't gotten into really what the complement means. So I think in this class, we are just going to use script I for irrational. And it means what it seems like it means. It's all the numbers that are not rational, given that they're real numbers. So we're just thinking of the set of all real numbers. So all those numbers that aren't covered by these 4 situations are considered irrational. And so some common ones like pi, which we know is 3.1415. It doesn't repeat. It doesn't have a pattern to it. It doesn't. It doesn't repeat a pattern, and so that's considered irrational. Now, other ways: square root of non-perfect squares. So the square root of 2. If you type that into a calculator, you'll see it's just a bunch of numbers that don't repeat, and it goes on forever. These are the 2 main. So we just have these constants that, like that, and then there's also like phi and e. Those are all constants that are irrational. But I think we'll just focus on these 2 situations, like pi, and then anything under a square root that is not a perfect square. Okay. Some